Right, so if you could just write from this part, so the idea is a very useful thing to help us to condense working and to condense the size of very big numbers. Right, when we're talking about billions and trillions, you don't have to keep writing all those zeros, it's very difficult. So to write a number in scientific notation, you look at the non-zero digits of that number, okay? And then you write those digits as a number, a decimal usually, between 1 and 10. Okay, so in our first example, with the 150 million kilometers, we'd look at the non-zero digits, the 1 and the 5. Well, the way we make that into a number between 1 and 10, 1 and 5 is, well, that's 1.5. So actually, that's 1.5. That's my first part of scientific notation. And then you multiply by the appropriate power of 10. So however many places you need to move your decimal place, you multiply that, you give that a power of 10. Okay, so if you move the decimal place from your decimal that you created, if you have to move it 8 places, then it's going to be times 10 to the power of 8. So if it's 6 places, it's 10 to the power of 6. And to make a note of this, if it's a large number, as in if we're talking about things like the size of planets or distance to the sun or the distance to the nearest star besides the sun. Does anyone know how far it is to the nearest star next to the sun? A very long way. How much is it? Yeah, it's a long way. 3 light years or something like that. A light year is the distance light takes. So light year is the distance that light travels in a year, which is a very, very long way. Okay, so the sun is 150 million kilometers away. That's about 8 light minutes. Okay, so if the sun exploded and or turned off, we would have 8 minutes of sunlight left, and then that would be it. Okay, so if the number is positive, it's a very big number, the power of 10 is positive, because the decimal place is moving to the right. If it's a very small number, it's a decimal, so if it's 0.000 something, then the power of 10 is negative. So when the power of 10 is negative, you move the decimal point to the left. When the power of 10 is positive, you move the decimal point to the right. Okay? Any questions about that? Yeah? Alright. So we're going to have a look at these examples. Write the following in scientific notation. First step is to look at the non-zero digits. We've got this 3 and 4 here. What are 3 and 4? How do I make a 3 and a 4 together between 1 and 10? You do 3.4. Alright, so I can say that's equal to 3.4. Now I have to times it by a power of 10. So I have to decide what power of 10 to use. If I start here with 1, 2, 3, 4. So we're moving to the right, so it's 10 to the power of 4. Okay? So that's 34,000 as a scientific notation. 3.4 times 10 to the power of 4. So I don't have to write all those zeros in. What about this one? Which are the non-zero digits of this very small decimal? 2 and 3. So how do I make 2 and 3 together between 1 and 10? 2.3 times 10 to the power of. Which way do I have to move the decimal point from 2.3 to get back here? Left or right? I have to move it left, so it's going to be a negative power. How many spots left do I have to move? 1, 2, 3, 4, 5. So what's the power of 10 going to be? Yeah, that's negative 5. Remember, it has to be 10 to the power of negative 5. And so that's the way that we do those two. Convert it in. You pick the non-zero digits, make it into a decimal between 1 and 10, multiply by the appropriate power of 10. Okay? Any questions? Right. Move it up a little bit. The other thing is, to go back the other way, you have to think, well, write the following as a decimal. 4.3 times 10 to the power of minus 3. Well, if I do 4.3, I'll just write the 4.3 over here. If it's 10 to the power of minus 3, it means the decimal place is moving left 3 places. So I do 1, 2, 3. So I have to put a 0 in both of those. And so it's going to be 0.0043 is how we end up. Okay, so you just got to write the digits and then think about how many zeros you have to insert either before if it's a decimal or afterwards if it's a big number. Alex, Alright. Now the other thing, there's two other things I want to do. Two examples of comparing them, and then one of using a calculator with scientific notation. So if I move up to here, when you compare scientific notation to see if one is larger or smaller, the first thing to do is compare the powers of 10. Because as soon as one power is larger than the other, you know that that one's going to be larger, regardless of this part. Okay, this part doesn't matter if the powers of 10 are different. So between these two, which is larger? If I remember this, you've got to look at the powers of 10, because 5.5 to the power of times 10 to the power of 5, or 8.9 times 10 to the power of 4. So the thing is, this one here is actually 550,000. This one here is 89,000. Which one is bigger? Yeah. So although this one, 8.9 is bigger than 5.5, but when you multiply it by that power of 10, this one is definitely bigger. Okay, so this one is the correct answer. You're going to look at the powers of 10. Which one's larger, and then you go with it. Now this next one, which is smaller? 2.3 times 10 to the power of minus 4, or 5.2 times 10 to the power of minus 5? Which one's smaller? Yeah, so again, the one which is smaller is the more negative one. So this one is 0.00023. That's this one, whereas this one here is 0.000052. So again, without writing it out, and by simply looking at the powers of 10, this one is smaller, and so this one's going to be smaller. That's our answer here. 5.2 times 10 to the power of minus 5. Now I'd like you all to get your calculators out, please. Okay, now, if you look on your calculator, you see there's a button that says log. See that button? It's sort of second row of the function keys, second one from the right. It says log. You see log? Yeah. Second one across. Now, if you do above it in yellow, it says 10 to the power of x. Do you see that? So that's our scientific notation button. So let's say I want to input this. 5.5 times 10 to the power of 5. What you do is 5.5 and then second function log and a little 10 with an arrow next to it comes up. And then I just put the power of 10, which is 5. Press equals, you get 550,000. Okay? Okay. So, this is the instructions for how to do it on your calculator. And so you input the number between 1 and 10, you do second function log, and you get that little 10 with the power, and then you put the power of 10. So if I want to do this operation, can you all do it with me? You do 4.3 second function log 4 divided by 6.5 second function log minus 3. Press equals. You get 6,615,000 something. Got that? So 6,615,384. What is this as in scientific notation? Somebody tell me. Let's do it to two significant figures. Jamie, how do I write this number into two significant figures? How do I write this number to two significant figures, Millie? Two significant figures. Somebody tell me, please. Two significant figures. Not interested in scientific notation yet, I just want to write this number to two significant figures. Good. 6,600,000 to two significant figures. And somebody change this to scientific notation for me, please. Let's say let me call. How do I write this in scientific notation? No, it's 1, 2, 3, 4, 5, 6. Okay? .6 times 10 to the power of 6 is the answer to this one. Okay? So you can do operations with the calculator with scientific notation. So exercise 1.10, question 1 to 4, first column. 5, 6, 7 AC only, and then 8 and 9 AC 10. Alright? Mrs. Mills is here to help. So please take advantage of that. Yes?